Welcome to Equinox, where Rob and I are striking the balance between the light and the dark. This is episode 15. My name is Joseph Darnell, and I'm joined by my good friend, Dr. Robert Carter. Hello, Rob.
Hello, Joe.
This is the first time that we have recorded in separate spaces, and I think that you might enjoy this in the long run with more recordings like this, but I've recorded many podcasts like this, and it took me a little getting used to recording together in the same studio with you when we started this show.
Oh, really? Because I was perfectly happy that we were together. This is odd for me.
Yeah, it would seem natural to be in the same space at the same time, and it's so much easier to get the visual cues from each other. But yeah. I don't know, like this was podcasting for me going all the way back to 2012.
One of my favorite radio interviews that I've ever done was with Steve Deace when he was on the big AM station out of Des Moines, Iowa. And I got to go to the studio. We were looking at each other through a piece of glass, but we were able to look at each other and kind of play off of each other and little sarcasm, a little joke here. We knew what we were going, and the chemistry worked out really good. I've done a lot of other radio interviews where it was just on a phone, and those are just a lot harder because I can't see the person. So I miss you, Joe.
Oh, I miss you too. I love your visits, but it's just actually a whole lot easier to edit a podcast like this. And so a little selfishly, I appreciate recording like this because when the two are in the same room, you get feedback from each other's talking on your mic, and then it takes a whole lot more editing to make it sound really clean. So yeah. I appreciate this for its convenience. Ordinarily the podcast recordings for Equinox are about an hour long. And we're probably looking at about 4 to 6 hours of editing, just depending on what happened. But wow. A lot of it can be just selecting the regions where your voice is on my mic and vice versa and muting them. And then making sure that we got it right at the right spot so that the audio is as clean as humanly possible.
I'm doing similar things with my own podcast and how hard it is and how I'm a newbie and how long it takes me to do my own audio. I can appreciate the art. You're a lot faster than me and you're a lot better than me. But yeah, this is going to be good. I hope the listeners appreciate the new sound.
Keyboard shortcuts, my friend. That is a lifesaver. If you get used to those in Adobe Premiere Pro, are you editing your podcast in Adobe Premiere Pro?
Yes.
It is so good. I know a lot of people who they should be using Adobe Premiere Pro, but they just don't know it yet. They need to get off of Logic Pro and...
But I wouldn't have known it either had I not been doing video. I mean, I was, editing videos, and then when I saw, now I want to do the audio stream and make a podcast out of it, I just loaded up in Adobe. I didn't know other people weren't doing that.
Well, the reason is that if you rewind the clock, you go back to when podcasters got started, they were using audio recording and editing apps, and they assumed that that was just the way to go. And so they've been telling every new podcaster, do what I do. And what I do is I use a audio recorder and editing app, but those are typically made for music studios and voiceover artists and vocalists, and they just don't have the same features. And those shortcuts that we use for editing video are also really good for editing audio podcasts.
Yeah, they sure are. So here you go. Everyone listening who's a want-to-be, newbie, want to get into the podcasting world, treat it like audio. Works better.
Yeah. Speaking of podcasting, our show is now on Spotify. So we're right up there with Joe Rogan. We're going to be popular now, and they're going to give us a big check. No, actually, I don't think that's going to happen.
I don't care about super popularity. I just enjoy doing this.
Have you ever listened to that show?
No.
I haven't.
Once or twice when someone said, hey, you got to listen to this episode. Oh, okay.
I probably saw a clip or two of his on YouTube and didn't even know it. And until it hit the news that he was moving to Spotify exclusive, I didn't even think about it. So I'm really happy to be on Spotify for all of our listeners. If any of you have friends that don't listen to podcasts because they live in Spotify, or they do listen to podcasts only within Spotify, they can now get Equinox. So be sure to tell your friends that it's there. As a little bit of a side note here, I'm very happy that there are people using Spotify to listen to podcasts now. But I want to recommend that if you are new at this, you want to subscribe to Equinox, look at some of the options because podcast apps are plentiful on both iOS and Android, and some on the PC and the Mac. The one that I love is Pocket Casts, and
that's what I use that too.
Favorite. It is so good. It is so good.
Yeah.
And I paid for a membership so that I could get some of the special features like running it on my Mac in addition to my phone. And that is so good while I work listening to podcasts. If I'm doing some graphic design, I can listen to the podcasts. It's great.
Cool.
So you wanted to talk about the rocket launch that went on?
Yeah, the huge thing. I just literally, this is after 6 o'clock Saturday evening, and it went off about 3 o'clock or 4 o'clock. I don't remember anymore. But just a couple hours ago, the United States launched their first 2 live people from United States soil. And it's just a huge milestone, and I'm really happy that Elon Musk didn't blow anybody up because he was worried about it. I like the fact that he said last week, he said, if this thing fails, it's my fault. That showed some pretty good leadership on his part. And I was actually impressed that he did that. But no, it went up without a hitch. But it's not only that the U.S. just launched 2 astronauts. It's also that it was done with a private company.
That is
and
really
that
neat.
changes everything. Because all of a sudden we have private industry being able to do something at like 1/10 the cost the government could do it. And private industry is going to get people to the moon and to Mars and to orbiting space stations and things like that.
That is pretty exciting.
This is really exciting. So totally exciting. It opens up a whole new world of space travel.
Do you see this working out for more citizens and people like us in the next 5 years or 10 years if we wanted to travel?
In time, it's going to be more than 5 or 10 years before it's cheap enough. By that time, I'll be too old. They'll be like, oh, your heart's not good enough, Carter. You can't go. Oh, man. All my life I've been waiting. Please let me go.
Well, they got to take some senior citizens eventually, right? You could volunteer.
I'll just let that lie.
Oh, well, when the time comes, we'll see if your attitude has changed. So last week we were talking about Interstellar and science fiction movies. And the reason this stuff comes up is we are a science podcast. We're not really talking about fiction and entertainment very often. But Rob and I got to talking about it, and we love storytelling in film. And one of the things that gets to both of us, really annoys us and also excites us, is the way that invention, ingenuity, technology, and science is depicted in films. And sometimes to great effect, and other times it's just flat out lousy. And usually the reason is because they took liberties and make the so-called science, it's really just fantasy elements. And so what we talked about were films where they've been loosey-goosey with science facts, and it's not effective, and it's inaccurate, and it's actually impossible in some cases. But then after we were talking about all of that on the air, you brought up that you have written a 1-page science fiction of yourself, and well, not of yourself, but for yourself.
I've actually written several short stories. I'm not saying any of them are any good, but I've written several just for the fun of it, just because I like exploring ideas. And it just so happens that I wrote a 1-page short story. I tried to put an entire story on 1 page of paper, and it was about Plan B from Interstellar. That is, how do you get life to other planets when the distances are so vast? We don't have wormholes. Yeah, wishful thinking as far as the producers of that movie are concerned. But if we just had to do it with real physics, it's going to take ages upon ages to get any spaceship from here to a different star. And so I figured, it's not worth sending people. It's not worth keeping people alive that long. What if we just sent frozen embryos? And so what I have is this very brief story of a vast machine in space that arrives around a planet orbiting a distant star, and it starts warming up, and it starts cooking embryos and raising little babies that get born in a machine, and they start getting educated by computers, and then they get to meet each other, and they become the first generation of people living on a distant star system.
I could see this actually becoming a film. It could actually be a film or a series, a television series.
The whole time I was writing this, I was thinking it would be a cool film.
Did you write this after Interstellar?
Oh, yeah. No. Before Interstellar.
Nice. So they stole the idea from you, and they didn't even know it.
That's right. They had no idea what I was doing.
Do you have this published anywhere online? Is this
just on Facebook? There's in our show notes for the last episode, there's a link to it. In fact, I just went to the show notes and clicked on the link to go find it to make sure I was looking at the right thing.
Excellent. Well, then if you want to look at that story, then go to nightowl.fm/equinox/14. So, speaking of that episode, we also got some feedback from a friend and listener of the show. Our podcasting friend TJ Draper wrote, "Tell Rob that the Stargate movie isn't great, but the series is amazing fantasy. Just don't watch it for the science." Now, you said you started the series, but you didn't watch it for very long, right?
No, I never bothered to watch the series because the movie was so bad.
Okay.
So maybe with that admonition from TJ, maybe I need to go and revisit it, and maybe there's actually something worth watching there.
Isn't that kind of the attitude that you have to take to approach a show like Doctor Who or Star Wars or even Star Trek 2?
Well, I tell you what, that first Star Trek movie with V'ger was really hard to watch, but then they followed it with Wrath of Khan, and that made it, wow, this was great. And so some of the Star Treks are good and some weren't great. Star Wars, of course, the first 3 episodes should never have been made, but we don't talk about that.
No, they shouldn't have.
That's in episode 1, 2, and 3, not the ones from the 70s and 80s, but the remakes. Oh boy, prequels. That's what they're called, the prequels.
I grew up with the prequels, and I knew at the time that I was
Really?
being suckered. Yeah.
Yeah.
I grew up with the original trilogy, but I was still very young, between the ages of like 9 and 15 while they were making episodes 1, 2, and 3. And I was super excited by episode 1, but disappointed. And then with 2 more so. And then with 3, I just really didn't care.
So we have to, it's called the willing suspension of disbelief. We have to go in there just to have a good time and not think too hard. But again, you got to tell a good story. But you just took a slam on Doctor Who. That's unfair.
Okay, so I'll take a step back. I've only watched like the Christmas special episodes because my sister roped me into them.
Oh, come on now. I'm going to tell you this, that just from a TV show standpoint, there's 1 or 2 episodes of Doctor Who that are the best standalone episode of any TV show I've ever seen from a writing standpoint. Just brilliant, engaging. One of them was scary. One of them was just cool. In fact, one of them made me cry. It's like, wow, that was so good. So
nice.
It's worth watching. It's not perfect. Some of them are dumb. Some are just a little gruesome. And, any show is going to kind of run out of steam. And I think they probably should have retired it a couple of years ago. Just said, okay, we're done.
Which season should I start with?
Oh, start with the new season 1.
The new season 1?
Yeah, the new show, season 1, not the old Tom Baker 1970s sort of stuff, which was really good too from a hokey standpoint. But yeah, just start there and just go through it. And
Well, I could give it a try. I don't have anything else I'm watching right now. I could give it a shot.
I'll just tell you that when Rose gets trapped in a parallel dimension and he's burning out a star to suck up enough power to project himself into the other dimension just so he could say goodbye, that brought tears to my eyes. That was such a cool concept. And then you're going to see one. Other people are going to know what this is. But when you see the episode Blink with the angels, oh my, that was scary and brilliant and just excellent writing. Just fantastic writing. But that's a couple years in before you get there.
All right.
Anyway.
Well, I'll give it a shot. I'll report back and let y'all know what I think. So you ready to get to today's topic?
Yeah. We've been doing all these episodes all this time and just randomly jumping around between cool ideas. And this is an idea that's actually earth-shaking. It makes us question what reality is, and it makes us question what we're made of. And that's always fun for me. I love those sorts of questions. I actually wrote this in an article that appeared in Creation Magazine, 2018, I think. And I just titled it, "We Are Less Than Dust." As in, less
It really
than dust.
disturbs me to ask the question that you mentioned a second ago, make us question what we think reality is. That sounds like a bizarro world question. Like, how can that even happen? Because, growing up, we think that the world is the material plus our emotions and experiences. We grow up and we're introduced to knowledge and resources and culture and a wealth of other emotions. So we get to the ripe adult age and we think we've got it all figured out. And then you're telling me there are sciences that can still make us question everything about reality. This sounds very interesting and I'm feeling intrepid going into this issue. What is this? What are you going to tell me?
Well, you remember you read this in the Creation Article podcast a while ago. I don't remember what episode it was. Oh, SO3E11. Is that season 3, episode 11?
Yes. It's been a while. Yeah.
Yeah, it has been.
Okay.
But
I remember this one now. Yeah.
Yeah, and it's weird, totally weird. Oh man, that brings something else up. Oh, I should have looked this up again. A long, long, long time ago, I did some calculations. I said, I am told that there's 10 to the 80th particles in the universe, which means hydrogen atoms mainly. I said, if I took them all and stuck them right next to each other, how big a ball of hydrogen would I have? And the answer was not nearly as big as I thought. Then I said, okay, what if I just took the nuclei from those atoms and got rid of all the electrons, just lined up all the nuclei, made a big ball of the nuclei of all the atoms in the entire universe. You know how big that ball would be?
Oh, could not fathom it. Not as big as the universe itself, that's for sure. A lot smaller.
It would be smaller than our solar system.
Are you kidding me?
It would be
whoa.
smaller than the largest star that we know about.
How is it even possible?
When we're talking about numbers, big numbers, scale becomes really strange.
Okay, are we talking about the traveling distance of the orbit of Uranus or Pluto?
Probably closer to Neptune, maybe.
Oh,
I don't remember
wow.
I don't remember what the number was, but it was a sphere of electrons. Oh, sorry, a sphere of nuclei, which would be impossible. You can't do that. You can't put them next to each other. But if you did, all the matter in the universe without the electrons would fit into something smaller than the radius of our solar system.
Ah, that is insane. Whoa.
All right.
Speaking of the universe, are we talking about the universe then? Or are we talking about matter?
The visible universe.
The visible universe all the way down to like a rock and all the way up to the largest star?
No, yeah, distant galaxies.
Okay, so we're talking about the big stuff, not the stuff on ground level of planet Earth or the moon. Okay.
Well, that's included too.
Okay, it's included. All right.
Yeah.
That's a lot to take in. Because even something like the sun seems so enormous. There's this great video that got around months ago of a animator who animated like a slide of all the planets to scale, like show you to scale, like here's the smallest moon in the solar system, and we're going to work our way up to the largest of the large celestial bodies. And
cool.
It shows you the moon and then moves away to show you the scale of the next thing up. And it gets all the way up to the scale of galaxies and nebulas. And it was showing you just how huge the sun is compared to things like Jupiter in the solar system. But then by the time you get to the end of this series of progressing larger and larger space bodies, it makes the sun look insanely small. It's hard to fathom all of this fitting into the space of the solar system.
Yeah, we're going to get into more insanely small stuff. You just wait. I've run some additional calculations besides what's in this article. It's just called, if you're interested, listener, creation.com, we are less than dust. But this is going to be a good summary of that article. So it got kicked off. I read Psalm 103:14. For he knows our frame and remembers that we are dust. And I said to myself, dust. What are we actually made of? What is dust made of? And that's when it hit me. It's made of almost nothing. And this is very humbling and shocking and strange when we realize that our bodies are almost pure, empty space.
That is really weird to think about. So can you explain that? Because when you say pure empty space, like I'm looking at my hands right now and my left hand is grabbing hold of my right hand and it doesn't feel like it's empty space.
Oh, that's a mirage.
You're not helping.
So you know that we're made up of atoms, right?
Yes, that much I learned.
Okay. Maybe listeners like, how do you know that? Okay, listener, the last 150 to 200 years of experimental science has told us we are made up of atoms. In fact, back in like 1800s, we didn't know what matter was made of. So Rutherford took a lump of gold or lead and he shot a whole bunch of electrons at it. And they went right through. A whole lot of electrons. They zip right through the matter. And every once in a while, they'd zing off to the side. And he was using like a phosphorescent screen to see them. So if you had a little electron gun and you shine it at like a gold foil, it would go right through it and you'd see a little dot with the screen. Take the foil away, you see a dot. Put the foil in front of it, you still see the same dot. There's no scattering of the electrons. But then every once in a while, he'd get a dot off to the side, which meant the electron hit something. But since most of them didn't hit something, he realized that matter is composed of very tiny little particles that we now call a nucleus. And the nuclei are spaced apart at great distances inside matter.
So is the idea that an electron is something of substance, but it's just so daggum thin, so small that it can travel through all the other substances then?
Yes.
Man.
Just like a neutrino is so tiny, most of the time it'll go all the way through the Earth without striking anything. It just misses.
Man.
That's really subatomic particles. I mean, electrons are hard enough, and we knew what they were in the 1800s. We didn't have any idea what a neutrino was in the 1800s. That took atom smashers and smashing things together. But all these experiments after all this time has just built and built and built and built and built. There's no question. There's no scientific uncertainty here. There's not a single data point that tells us that matter might be something different than what we think it is. And that is a tiny little positively charged nucleus surrounded by an electron cloud.
So the positive charges is what holds the atoms and the matter together?
No, that would be the strong force.
The strong force. I'm not familiar with the strong force. Is there a weak force?
Yes, there is a weak force and a strong force.
Okay.
And gravity and electromagnetism. Those are the four fundamental forces that hold everything together or push everything apart.
Oh,
you see,
okay.
You know, like you can't put two north ends of a magnet right next to each other, right? They push apart.
Yeah, right.
Well, you can't put positive charges right next to each other. They fly apart. Positive attracts negative, but positive repels positive.
Totally.
Okay.
So what does that
how
mean?
do you? Well, what it means is if you take a bunch of positively charged protons and shove them together into this little tiny thing called a nucleus, the nucleus should explode. So we have the strong force holding it together, and it's incredibly strong. And if it didn't exist, we wouldn't have matter.
No. So I'm going back to something I heard probably more than 10 years ago. I remember hearing that researchers were trying to understand what held atoms together. Was that a research that was going on at the time, or was I reading something dated?
They've been trying to figure this out for a long time. Like we call it a force, right? But it might be a particle like a gluon or something that's binding it together. But actually, no, it really is a force. So sorry, it's not particle-based. It's force-based. And all the experiments are telling us that.
This sounds like reality is imitating fantasy now.
It gets so weird so quickly. When you start getting into smaller and smaller and smaller dimensions, things just don't behave normally anymore. The same way like, we're talking about all these things with Einstein in previous episodes. Like Newton was great. All Newtonian physics works wonderfully well until you get to things that are really big or really fast. And then you need Einstein. But on the other end of the scale, Newtonian physics breaks down when you're at the really tiny and really small scales.
Oh,
and that's where we get quantum physics.
Does that have anything to do with this then? Does the quantum mechanics or the quantum realm have something to do with the electrons? Like, are electrons in the quantum realm?
Yeah, they're on the edge of it.
So it's not like we could actually see the quantum realm because it's just so small.
Yeah, I'm going to say that it's smaller than electrons.
Okay.
Just to keep it real simple. But electrons, problem is, I just made a mistake here because I can't use any other language. No other language works. Electrons have no size.
Okay, so then how did they see
They have
their
a mass. They have
Okay.
a tiny little mass. They must have a tiny little size, but they're so small, it's essentially no size. And it gets weird. And that's a weirdness. It's just, we got to just take it as is because all the math and all the experiments say it's just the way it is, buddy. Just accept it.
Okay.
Okay. And that's why if you strip away all the electrons and put all the nuclei together, you get a very small volume. So the electrons are really, 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 really small, which means that, and here's the kicker, if you have a molecule, you have nuclei separated by vast distances with nothing in between, because the electrons essentially don't have size. There's a force there. There's electrical force, but there's not really any substance there.
It's hard to fathom because I think one of the reasons this breaks my mind is because I think of electricity and that just means energy to me. And that means something that powers our equipment and technology in our homes and buildings and vehicles. It doesn't sound like energy could also be holding together matter in arranged orders for things like the fingers on my hand. It doesn't sound like energy has anything to do with that.
It's all energy, man. All energy. And when I start talking about this, I start thinking Matrix. Like
Matrix,
the movie
as
The
in the
Matrix.
movie The Matrix. Okay.
Yeah, when everything disassembles into numbers and strange codes and things like that. That's what I think of when I consider what I'm made of. I'm just an energy ball.
So now you're going to have people wondering, are you saying that reality is a virtual reality?
No, it's concrete and physical. But on the other hand, it doesn't mean that this is all there is. It's like, people say Jesus walked through a wall, during the not the Last Supper, but after he rose from the dead, he appeared to all the disciples who were in a locked room. Now, the Bible does not say he walked through a wall. It says he appeared to them. But what if he did walk through the wall? Is that because he was a ghost or because he's solid and we're a ghost?
So it's like he is a different kind of matter running off of a different kind of physics or off of a different type of dimension?
Like he's more real, more physical, more solid than what we consider the physical world.
And you're not saying that he had to be this way.
No,
it's
no,
just
no,
that
no,
it
no.
could have been this way.
Yeah, like it says, so instead of heaven being ghostly and ethereal, it's actually more concrete and we're ghostly and ethereal.
I like that theory. I buy that theory more because I don't think that heaven and eternal places are ethereal. Yeah, just ghostly spiritual dimension. Because
I don't.
spirits don't necessarily have the five senses per se. Aside from, well, I mean, most spirits are human and angels, but those are creatures. And
Yes.
so if a human, a creature, has a spirit, his spirit isn't able to detect things apart from the physical senses for the most part. Like, if I don't have eyes, I cannot see. If I don't have hearing with my ears, I cannot hear.
Yes.
So I just cannot imagine a spiritual dimension where spirits are able to borrow some of the properties of the physical universe and not have bodies with them to take advantage of the five senses.
But that's just it. Angels do have bodies. They are physical. They're solid. They can just appear and disappear in our realm. So the question is, do they have a body just like us, or are they like different than us, and why? But let's back it down a little bit. Let's talk about us a little bit more because we have to grab reality a little more deeply before we can really understand the whole concept. Imagine an atom. How big is it?
I don't know that I can quantify this. I'm going to say it's smaller than a flake of dust.
Much smaller. A standard hydrogen atom is 100 picometers in diameter. That's 100 trillionths of a meter.
So it's probably, well, on the scale of like the thickness of a human hair, it's still much, much thinner.
Yeah. Okay. Let's talk about big numbers here, or big, tiny numbers. A millimeter, right? We've all seen yardsticks or meter sticks, shall we say, and a meter stick has centimeters on it, and it has these little teeny lines. They're called millimeters. There's 1,000 of them in a meter, and so it's 1,000th of a meter. Now, in mathematical terms, we say 10 to the negative 3, because 1,000 is a 1 followed by 3 zeros.
Mm-hmm.
So a 1,000th is 10 to the negative 3, is 0.001. Smaller than that, the next big step is a micrometer, a millionth of a meter, or 10 to the negative 6. Smaller than that is a nanometer, a billionth of a meter, 10 to the negative 9. Smaller than that is a picometer, a trillionth of a meter, 10 to the negative 12. It would take a billion hydrogen atoms lined up side by side to make 1 millimeter.
Okay.
It would take a trillion of them lined up side by side to make a meter. That's how small a picometer is. It's a trillionth of a meter. Now, we can get to femtometers and attometers and things like that, but in science, we don't really use those names. We just use the exponent. So 10 to the negative 9, 10 to the negative 12, 10 to the negative 15, 10 to the negative 18. That's what we say. So a picometer, trillionth of a meter, is 10 to the negative 12 meters. That's how tiny a hydrogen atom is. You okay with that?
Yeah, it just gets really weird at the scale.
Totally weird.
Because if you think of having a lot of hydrogen in a single space the size of a basketball, that's a lot of hydrogen atoms. Like a lot.
Yeah. Oh, I just lied. We do need femtometers.
Oh, no, we do need femtometers. Oh, don't forget them. Oh.
Well, we're going to talk about the size of the nucleus. So we're going to go down to the quadrillionths of a meter.
The size of a nucleus. Nucleus makes me think of it's some sort of like filmy. You know, like if you get some glue on your fingers and it dries and you kind of rub it off and it looks like dead skin. That's what I think of a nucleus is.
Wow.
What is a nucleus?
Think of a walnut, hard, tough, a walnut, and just make it really, 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 really small. And it has amazing positive charge to it.
Oh, okay. Very different sort of properties than I pictured.
Oh, yeah. Very different. But the hydrogen nucleus is 2.4 femtometers. 2.4 times 10 to the negative 15 is 2.4 quadrillionths of a meter. That's a zero with 0 point, and then you write 14 zeros, 24.
It would take a lot more space to write out the number than it would be to quantify the scale of the nucleus.
Yeah, that's why we don't write numbers like that. We write them in scientific notation. So 2.4 times 10 to the negative 15th meters is the diameter of a hydrogen nucleus. That's really tiny.
Mm-hmm.
The electron, the electron is not, there's not like an electron. There's not a physical thing that's an electron. It doesn't quite exist as a physical thing in very strange ways. And I don't really want to explain all the quantum dynamics of it, but we just say that it exists as a cloud.
Okay.
You can't put your finger on it and say, there's the electron. It's all places at the same time around the nucleus. But the average distance of this cloud is 60,000 times the diameter of the nucleus.
Okay. Yeah.
So in other words, from the nucleus to the edge of the electron cloud is basically nothing. And it's very big compared to the size of the nucleus.
Right. I'm with you there.
Okay. So
because think of it this way. If we take the smallest thing, if we're going with the scale of the hydrogen atom in the nucleus, if we just were able to say like, honey, we shrunk ourselves and we're down on that scale, can see the hydrogen atom and its nucleus, then we would perceive that the electron, if we had eyes to see it, is bigger, right? That's what you're saying?
I'm not sure.
I'm trying to visualize it here.
I'm not sure you can visualize it. We can just talk about it and wonder.
Okay, if we were Hank Pym from the Ant-Man movie and we could use the quantum realm shrinker device.
Okay.
Yeah. Then it would look a lot bigger than we would if we could get ourselves on that scale.
I don't think you can see the electron, but if you touch the electron cloud, it would all absorb into you and you get a big shock.
Okay.
Imagine it's like a fog. Scale. It's a fog, but if you touch it, the whole fog goes and sucks into your finger. Ouch.
So does that mean that electrons are, once they're absorbed, where do they go? Does that mean they just don't exist anymore? Or can they recycle?
Oh, that would be another topic for another day. What happens to electrons and protons and photons? That's really some cool stuff. But no, basically they usually get captured by another atom, and now you have an ion. Or maybe you neutralize an ion, and you now have a well-balanced atom.
Okay.
Electrons get passed around in biology a lot. This whole electron transport chain that we use to make energy all the time. We got a vague idea of how small an atom is. Now let's talk about a molecule. Like the most common molecule.
Significantly bigger, right?
Well, yes. H2. Two hydrogens stuck together. It's about 74 picometers in diameter. Or the most common bond in the body is probably the hydrogen-carbon bond. That's about 109 picometers. So a bond between the two atoms is about 100 picometers in diameter. This giant electron cloud. And inside it, two tiny little nuclei. Let's blow it up and let's magnify it so we can see how far apart these nuclei really are. Let's make one nucleus as large as the sun.
Okay. That's
how far
big.
away is the other nucleus? So when we draw molecules, you draw two circles and you draw a line between them, right?
Yeah.
So make one circle as big as the sun. Where's the other circle? Is it as far away as Mercury?
I'm guessing farther.
It's actually 14 times further away than Pluto.
What? That is a lot of space.
These two suns would be 100 billion miles apart, and in between is nothing but empty space.
That's not, if we could quantify the scale then, that's not, say, like the scale of 1 light year or something like that?
Hey, let me look that up. 100 billion kilometers light years. It's a tenth of a light year.
Still pretty far.
So it's about a light month apart. Wow.
That is astounding.
Okay, but at that scale, how big would the sun be? If you were standing on one of these suns and looking at the other one, how big would it be? Well, from Earth,
man. Yeah?
from Earth, the sun is a half a degree. That's how wide the sun is from Earth. It's a half a degree. That's just a cool number to know. Well, at Jupiter's 5 times further away than the Earth. The sun would be 1/5 the size. It'd be 0.1 degree. Ooh, that's tiny. Be a bright little teeny dot. What about a Pluto? At Pluto, it would be 1/100th of a degree. I mean, a degree, if you look at a protractor and you look at the little degree marks, you can see how far apart they are.
Yeah.
But you couldn't tell 1/100th of a degree. Your eye could never focus on that. It's just too small. Well, if you're 14 times further away, you're talking about 0.0009 degrees. You could not measure the width of this thing. It's so tiny.
So clearly we're not standing on it then.
Well, true, but if you could make yourself like really, maybe you're on planet Earth, and you're looking at this other star that's connected to this molecule, or this other nucleus we're calling a star, and it's so far away, the other star would be 1/10,000th of a degree in width. That's how big the nuclei are compared to each other in a standard molecule.
Man, that's terrible. So small.
And in between, there's nothing. And therefore, we're made of empty space.
So I'm thinking then that for all of the atoms, that there's a lot of atoms.
Yes.
Is that what it kind of boils down to? Is that on that scale, for like all the atoms of my hand, has anybody even quantified how many atoms there would be in a particular type of object?
Oh, yeah.
Like, could we say how many atoms there are in a baseball?
Yep.
Or could we say how many atoms there are in an old-fashioned marble?
Yep, that's standard chemistry and physics, yeah. And in fact...
But even though the number would be pretty high, it's also relatively low.
No, if you count them, it's a phenomenally large number. And we don't even use regular numbers. We say it's so many moles.
So many moles? Why moles? Who chose that term?
There's a guy named Mole who figured this out. One mole,
of course,
is 6 times 10 to the 23. So if you took 1 gram of hydrogen, let me get this straight. Because hydrogen is just made up of a proton and an electron, a standard hydrogen atom, if you had 6 times 10 to the 23 of them, you'd have 1 gram.
Oh, man. Yeah, it's still a lot, yeah.
Carbon weighs, I believe, 18 atomic mass units. So if you had 6 times 10 to the 23 carbon atoms, you'd have 18 grams.
And it takes just 17 grams of coffee beans to brew myself a cup of coffee.
You can calculate the number of grams of caffeine from that figure right there.
Oh, that is so cool.
All right, so all this is crazy stuff. But the point is, when you're looking at something, you're literally, like your hand, is 99.999999999% empty space.
That is so weird. That is so weird.
So how do you see your hand?
Physical and material. Yeah, everything physical and material feels so solid.
Yeah, and it's so empty. James 4:14. What is your life? For you are a mist that appears for a little time and then vanishes. Ouch.
Very, very careful observations in Scripture.
How do we see things? If we're almost emptiness, if we're almost nothingness, how do we feel and touch?
Rob, I'm just looking at my hand and waiting for it to vanish in front of my eyes.
Well, it can't, because there's an electron cloud surrounding all those little teeny nuclei, and the photons coming from the light. Do you have sunlight coming through your window, or do you have a lamp turned on in the room?
I do. I have both.
Okay, so the photons streaming from the sun and flying through your window, striking your hand and bouncing off, that's what you're seeing. You're seeing photons reflected from an electromagnetic shield. It's a cloaking device.
Oh, man.
You're cloaked.
Whoa. And I didn't know.
If you could strip away those photons, it would... have you ever seen a loofah? One of those sponges. It's a rough, scrubby thing that ladies use in a shower to buff off, loose skin and stuff like that. Yeah. Well, that used to be a gourd.
Yeah, I'm looking at a picture of them right now. It's classified as a vegetable.
Yeah, you get rid of the gourd parts and it's this tough skeleton on the inside. That's much more substantial than your hand. In other words, if you got rid of the photons that were reflecting and stripped away the electron clouds, your hand would be less than a loofah.
It doesn't even look all like that much. Yeah, it looks spongy. It looks like it's got lots of holes in it.
Yeah, but the holes, you have more hole than you have substance in your hand. There's nothing there.
That is so weird. And it's an ugly plant too. Oh.
Yeah. So take a brick and smack your head with it.
Or don't. But
why not?
Imagine you did.
A brick is empty. Your head is empty.
Well, not empty enough.
Why?
The head tells me it's not very empty.
Yeah, but what is your head detecting? It's detecting so many nuclei surrounded by so many electron clouds, and it happens to be a lot of them, relatively, in a small area, small volume. So if you smack your head with a marshmallow, you wouldn't even feel it. But a brick's a little different because it's so much denser. But even at that density, it's still almost empty. It's a little bit more dense than a marshmallow. Marshmallow's a little bit more dense than a cloud. But comparatively, there's still nothing there. Psalm 89:47. Remember how short my time is, for what vanity you've created all the children of man. Sorry, I'm laughing just because when we consider our mortality and we consider reality, all of a sudden we realize that reality is really tenuous.
Man. It is difficult to think that this is just a constant that envelops everything and everything is built on. It is the foundational level. It's difficult to perceive it this way. I think growing up in a world not knowing these sorts of things and then learning about them sometimes is harder than just moving forward with reality as we imagine it which is actually not consistent with reality if we don't buy these things. You talked about the suspension of disbelief earlier. I have a problem closing the gap for belief.
But most people don't consider these things because they're so uncomfortable. It really is. It's theoretical scientists who sit around. Hey, you ever wonder about X, Y, or Z? Oh, that's really strange. Well, yeah, that's really what we're made of. No way. Most people don't like the thought because, first of all, the math is hard. Second of all, you have to believe things like atom smashers and atomic theory. And, most people are like, how do they even know that? I mean, I remember sitting in high school chemistry class and I said to myself, how does he know that? That can't be true. I think he's just making this up. I was thinking those thoughts because what he was telling me is just nuts. My teacher was telling me some story about he was trying to clean his window and he didn't have the proper window cleaner, but he had a really strong acid. And so he put it on a rag wearing gloves and he wiped it on his window and really quickly wiped it off and sprayed it down with water because he didn't want to pit his windows. Like, how does anyone know that? Oh, come on. Plus, and again, it was really kind of dumb because it would have kind of like, decayed the glue, what's that stuff called? The mastic, the putty, the whatever's holding the window pane in place. He's hitting it with acid, man. That's kind of dumb.
Yeah. The caulking. Yeah.
That's right, the caulking. But then again, the acid could have had zero effect on the caulking. It all depends on the chemistry.
It's true. Huh.
Weird. Wow. Anyway, all this crazy, cool, fun, amazing, lovely stuff. And yet, even though we're made of nothing but a vapor, God made us for a reason.
Yeah. Puts our lives into perspective that he wants us.
Yeah, even though we're empty and we're just a shell of nothingness. Psalm 8. Yet you have made him a little lower than the heavenly beings and crowned him with glory and honor. You've given him dominion over the works of your hands, and to put all things under his feet.
Incredible.
Listener, I know that can be hard to listen to because everything gets really strange really fast, but we are really important in God's sight. And even though, this material world we live in is really a vapor, there's a purpose for it. It is real. It's as real as it's ever going to seem. It's not like it's a mirage. It's not like it's fake. It's not, Eastern religion sort of stuff. But there is a God who did create us, and he made us for a purpose. And if you don't know that God, Joe and I want you to know that God. So contact us if you want.
Absolutely.
Go to creation.com, look it up. Go find a Christian to talk to. Ask them what it all means. Because some really, really cool and interesting and amazing and fun things still to discover. And when your eyes are open to the other side of reality, to the spiritual side, it's a completion sort of thing. Because I know in my own life, I was empty and searching and felt so alone until I met this God.
On that note, thank you so much for joining us on this quest. And you can definitely catch up with Rob to discuss these things, or you can send questions to us if you want us to discuss these things more on the podcast. Let us know what you think. If you want to dig deeper into the topics, you can find links to the stuff that we have discussed on this episode in the notes on the website. Hop over to nightowl.fm/equinox/15. Or if you're right there, the show notes are also with this episode in your podcast app. And you should also check out Rob's science videos at biblicalgenetics.com, his Facebook page, or his YouTube channel, where you can see the videos and join discussions about the topics he brings up there in the comments with the other people watching the show. And if you want to catch up with me, I'm also on Twitter at JCSDarnell. Until next time, goodbye, Rob.
Goodbye, Joe.
And thanks everyone for listening to Equinox.